Hello, everyone. Good afternoon. Respected authors and invited guests, welcome to the technical session 3D. Myself, Gayatri Burguda, and I'm going to be the moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of the conference is being organized in hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from 9th to 11th April 2026. I hope you all will enjoy the knowledgeable sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. I will raise a gentle reminder upon 9 minutes. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. And just before we start the session, I would like to introduce you all to the session chair for today. I'd like to welcome Dr. Amar Bachare. He is an associate professor at Vishwakarma Institute of Information Technology, Pune, India. He has over 18 years of teaching experience. His primary research areas include distributed systems, cloud computing, distributed system security, computer networks, Internet of Things, and blockchain. Sir, would you like to address the participants?
Okay, so thank you very much for nice introduction. So this is a good opportunity for the participants, authors to present the paper. So thank you very much.
Yes, thank you, sir. Thank you so much. Now, I'd like to move on to the presentations. I'd like to call upon the first presenter for today's session, Mr. Sarthak, to present his paper titled A Hybrid AI Terminology Microservice for Dual-Coded Ayush EMRs. Sir, you may start presenting now.
Am I audible?
Yes, sir, you're audible.
Do I need to open the camera or I can present?
Yes, you can open the camera and present it.
Thank you, sir. Is the screen visible?
Yes, visible.
Fine. So, good afternoon, respected judges, researchers, and fellow participants. I'm Sarthak, and today I'll be presenting our work titled A Hybrid AI Terminology Microservice for Dual-Coded Ayush EMRs. Healthcare today is rapidly becoming digital, but there is still a critical gap when it comes to integrating traditional medicine systems like Ayush into standardized global frameworks. This problem still seems small in itself, but solving this would create a big impact, especially for interoperability, research, and large-scale healthcare analytics. Let me walk you through how we approach this problem. So clinicals usually write diagnosis in short free-form text like burning chest after meals, or joint stiffness using systems like ICD-11 biomedicine, ICD-11 traditional medicine, Namaste for Ayush. The challenge is these systems are complex, pre-text is ambiguous, existing EMR don't support integrated dual coding. So clinicals are focused to manually search codes, which increases the effort, reduce accuracy, and creates inconsistent healthcare data. Existing AI-based coding system mainly focus on biomedical data only. They do not handle Ayush terminology, dual coding workflow, or free text clinical language used in real practice. So there is a clear last mile gap between what clinicals write and what EMRs require. Our goal was to bridge this gap with a practical deployable solution. We propose a human-centric AI-assisted terminology microservice. The key idea is to take free text input, understand it using AI, convert it into standardized codes, return dual-coded outputs ready for EMR use. The system ensures standardization, interoperability, and clinical usability. The architecture, our system follows a hybrid microservice architecture. First is Spring Boot backend. Spring Boot backend manages terminology graph, handles Namaste ICD-11 mappings, provides EMR APIs. The Python ML microservice takes clinical text, uses TF IDF plus linear SVM, predicts diseases categories with confidence. Orchestration layer combines output with terminology, applies safety rules, returns final dual coded output. The design ensures scalability, modularity, and easy integration with EMRs. The core innovation is Silver Standard dataset. 3,250 clinical descriptions we have taken, covering 75 diseases, augmented to 6,600 samples. Hybrid AI and deterministic systems, the AI handle understanding, backend ensures correctness, and confidence threshold, we have decided to keep it as 0.45. If low confidence, there is a fallback to manual search, which introduces the human in the loop. And so that moving to results, our model achieved top 1% accuracy, 96.74%, top 3% accuracy, 99.83%. Macro F1 is 0.9665, coverage is 99.5%, and latency is less than 200 milliseconds. The key insight is even if top prediction is not perfect, the correct diagnosis is almost always in the top 3, which is significantly reduces clinical effort. One critical aspect is safety. We don't blindly trust AI. If confidence is less than 0.45, system rejects prediction, switches to manual mode. This ensures no unsafe auto coding, reliable clinical uses. To conclude, we successfully bridge gap between free text diagnosis and standardized coding, enable dual coding across iOS plus ICD systems, provide a scalable EMR-ready solution, and the future works includes real patient data, advanced NLP models, and national level integration. Thank you for your time and attention. I would happy to take any questions.
So I do not see any comparison of your work with the existing system, basically.
The existing system is a standard EMR system, which does not include the proposed iOS EMRs, which uses Namaste codes. The standard EMR system only uses ICD biomedical code, which is only for which is not for Ayurvedic codes, which are Namaste codes. So we have implemented the Namaste codes in our system, which maps the Namaste codes and biomedicine codes together so that doctors can just search the
So you are
disease.
mentioning 75 diseases are covered, right?
Yes, sir.
But your actual focus on which disease?
Now we have not chosen any particular disease or disease categories. We have trained the model on many different diseases. So there is not focus on any particular type of disease.
Okay, thank you very much.
So can I close the screen?
Yes, you can close this.
Thank you.
Next. Gayatri, madam, please. Next.
The next presenter. I would like to call upon Somini Devi Veeram Machanini ma'am to present her paper titled Adaptive Hybrid PSOGD with Stagnation Detection for Robust and Efficient Multimodal Optimization. Ma'am, you may start presenting.
Am I audible?
Yes, you can continue.
So good afternoon, sir. Good afternoon, everyone. Wait, let me minimize this. This is Saumini, currently working as assistant professor at Mahindra University, Hyderabad, India. And today I'm going to present our work titled Adaptive Hybrid PSO Gradient Descent with Stagnation Detection for Robust and Efficient Multimodal Optimization. So this is outline of today's presentation. First, I just want to, what motivated us to go beyond, to go this work is, we all know about how does actually optimization happens given a function. The basic thing is gradient descent, and other thing is the PSO when the multimodal comes into picture, and also PSO is also a no gradient method. If we can see the particles swarm optimization, it's basically a population-based stochastic optimizer which takes a swarm of particles. Initially, it starts with some group of random points and tries to move towards the optima. And it's very strong in the global search capability. Whereas gradient descent is, when we take upon the local convergence, it's much faster than compared to PSO. And PSO is slower in convergence when it reaches near optima. And we also see that will be a premature convergence when we take multimodal landscapes. And coming to gradient descent, it can easily trapped in the local minima. And it's not suitable as a standalone global optimizer. So why can't we combine this PSO and gradient so that we can take advantages of both global search and local search? So the key insight is to combine PSO's global exploration capability with gradient-based local refinement so that we can overcome both the limitations. But when to switch from PSO to GD or GD to PSO matters here. So is it that there are no methods exist? No, there are some methods exist on hybrid combining PSO and gradient. So, and these are mainly categorized, three categories: coupled, sequential hybrid, adaptive hybrid. In the coupled hybrid methods, basically, the gradient information will be embedded inside the PSO update equations. And in sequential, once, let's say, PSO will be starting in the initial, and after specific iterations, it switches to gradient descent or vice versa in alternating phases. And yes, there are some methods exist here. And coming to adaptive, the local search activated based on the swarm dynamics, and our approach falls into adaptive. Under adaptive also there exist few methods, but what remains is, we can see from the coupled and sequential, it rely on static or heuristic switching. We have to either after a fixed number of iterations switch from PSO to GD and so on. And stagnation handling is limited to re-randomization or velocity resets in existing adaptive methods. That is, whenever the stagnation got detected in the existing methods, they will re-randomize the particles again from the initial some positions. They are not using the whatever is learned till then. So our approach, the adaptive gradient-based refinement of promising regions, remains underexplored. So we have done our work into this. So we can see with the fixed switching schedules or manually set thresholds, there are some limitations such as premature exploitation. That is, entire local search is triggered too early, and wasted computation. Let's say if we are fixing some iterations, if before some iterations, if the refinement is already done, we are unnecessarily doing. And suboptimal solution, it's a very inflexible balance between exploration and exploitation. That is a global and local optima. And our contribution is an adaptive hybrid PSO-GD where stagnation detection triggers the local refinement only when required, not unnecessary, let's say after a specific set of iterations and so on. And there, once stagnation is getting detected, we use ADAM optimizer for stable local search. So what is the overview is, our objective is to combine the global exploration with efficient local refinement. So, and the core idea is, you trigger the gradient-based refinement, that is local refinement, only when swarm stagnates, only when stagnation got detected. So the flow is here. First, let's say we start with PSO. We keep on exploring the search space, let's say global search. Whenever stagnation got detected, that is, there is no improvement in the particles, then we try to apply local refinement in the best solution as of now we have obtained. And then again continue PSO to explore. So the major difference between the existing adaptive techniques and our technique is, we already found the best solution, whereas existing methods are restarting or switching from the initial points, random points, which is very waste of time. Coming to PSO formulation, there will be some set of points. Each particle will have some velocity and position. And if you see the velocity update, it happens using the given equation, whereas the first component tries to move in already existing direction or its previous direction. Whereas the second component, that is C1 R1 personal best, it influences based on its own local best. Till now, in which direction it found the best solution. Whereas the third component is global best. Till now, among all the particles, which particle has converged towards the best solution. So basically, PSO updates its direction from one point to another point. It moves based on these three factors: its own direction, its personal best, that is its own best till now, and the entire swarm of particles best. So it combines, tries to see the average of all these, weighted average. And once the direction is known, it tries to update its position based on the direction. So how this weight is learned? This is all predefined, linear inertia weight decay. We start with some random W max as and when the iterations, that is T is number of iterations, I would say. So initially we can see T will be 0, so your W will be more high, so that the large steps we will make initially, so that we try to explore the entire search space. As and when T increases, our W decreases, so that our step size is reduced. So we are almost reached to the optimum, and there we are trying to explore more. But sometimes what is the limitation of this is PSO may stagnate near local optima. So our core idea is, whenever the stagnation got detected, how we are detecting the stagnation is, we can see when there is no improvement after set of iteration. You can see the global best at Tth iteration. The difference between the global best at Tth iteration is same as over some T minus patients, means we are specifying some window of size P or patients. If the difference is much less than some threshold delta, then we say that stagnation got detected. There is no much improvement, or small set of iterations P. So then we try to apply the local refinement, and we try to apply Adam refinement on this existing global best as of now we found, and try to return this refined solution to the swarm, so that swarm utilizes this best solution and all entire particles try to move towards this best solution. So here the refinement is applied only when needed. It is not scheduled after specific set of iterations or so on. Why only Adam? Why not normal gradient descent? Yes, Adam adapts the step sizes using fast gradients, leading so that it leads to faster and more stable convergence than the standard gradient descent. We can see here Adam is using the direction, and you can see the V is adaptive scaling step size. So the step size automatically changes based on the existing position. And this is the overview of our algorithm. We'll initially start with some set of particles and its velocities. Randomly we'll start and try to evaluate and set the global best. And for specific number of iterations, we try to update the weight, inertia weight. And for each particle, we try to update its position and velocity, also called as direction. And try to update the particle's own best or local best or personal best. Then once we update this, we try to update the global best. Then we try to check, once the global best is found, we try to check for the stagnation detection condition. If the G best is almost same for specific set of iterations P, then we try to apply Adam refinement on this global best and try to feed this global best to all entire set of particles. That's what the design highlights is. First, PSO handles a global exploration part. Once stagnation detection is found, then Adam refinement works only when stuck, and this refined solutions feedbacks to the entire swarm. And one more main advantage of this is we are not using any extra hyperparameters beyond what standard PSO and gradient is having. So why does it work? We all know that PSO explores has more global search capability, and stagnation gets detected because of lack of progress. And we are trying to use Adam so that it refines this existing global best in the promising regions. And when we are giving this feedback to the entire swarm, it obviously improves our search quality.
Excuse me, ma'am, you have
Yes.
1 more minute left
Yes,
to
yes.
conclude your presentation.
Sure. Coming to the experimental setup, we have tried on 7 benchmark functions: Spear, Rosenbrock, Rastrigian, Ackley, Revanks, Kiffel, and Levy. And these are the key parameters we have tuned and set. We can see we are comparing with the 3 baselines: only PSO, only gradient descent, and fixed switch hybrid method, and adaptive, which is ours. The final objective loss is much less when compared to other baseline methods for almost all the functions except on Squiffle. The Squiffle PSO is performing better than our method. And these are the convergence curves. The red one is ours, and the remaining colors are the baseline methods. We can see almost in all the functions, ours is performing better. These are the key findings. We are getting the best on almost 6 out of 7 benchmarks and strong performance on all multimodal functions. No extra parameter tuning is required, and it's only difficult on SquareFile, and it outperforms fixed switching method. Coming to conclusion, we have proposed this PSO GD combining PSO with ADAM-based refinement and stagnation detection dynamically balances both exploration and exploitation. And it's giving strong performance across both unimodal and multimodal functions, and no hyperparameters are required. Coming to the future work, we want to try this on the real-world optimization problems and also incorporate some constraint handling mechanisms and try to tune automatically this parameter and all. Thank you for listening to the presentation. If you are having any queries, feel free.
No. So good presentation and good work. Which parameter is mostly affecting stagnation?
Stagnation, sir. Affecting stagnation or detecting stagnation?
Detecting stagnation.
Let's say currently at a tth iteration, my function value is 5, let's suppose. And at t plus 5 iterations also, my function value is almost around 5.001, 5.06. There is no much improvement. So the difference between these two is over a set of iterations, it's very less than some threshold. So then we are saying there is no improvement in this region, try to move to some other region. Here you might have struck in local optima.
Okay, what is the threshold value you are taking?
Threshold is 10 power minus 6 in the real functions which we have tested.
Why it is so?
Sir, it cannot be 0 because obviously there will not be exactly same value or specific iterations in any optimization problem.
Okay.
So, but very less we took.
Okay.
Or specific, so let's say 10 iterations. If there is only this much change, okay, there you got somewhere you got struck. So try to move to some other in the search space.
Thank you very much.
Thank you, sir.
Thank you so much, ma'am, for your presentation. Now I'd like to call upon the next presenter, Rida Hijab Basit, ma'am, to present her paper titled Agentic AI in Supply Chain Management Systems, a Systematic Review. Ma'am, you may start presenting now.
Am I audible?
Audible, please go.
Okay, so my name is Rida Hijab Basit, and I'll be presenting on Agentic AI in Supply Chain Management. It's a systematic review. So basically, Agentic AI is largely being used in supply chain management systems, and this has given a drastic shift from traditional rule-based systems to automated, goal-oriented systems that are operating without human intervention. And the organizations who have used or incorporated agentic AI in their business processes have actually reported efficiency in their operations and cost effectiveness. But despite the advantages, the use of agentic AI has raised.
Excuse me, ma'am.
Gigi.
Ma'am, your screen isn't visible.
Just a second.
PPT is visible, madam.
Yes, it is visible. It was visible.
Okay, there must be issue from my side. I'm so sorry. You may continue.
Is it visible?
It is visible.
Yes,
Okay.
yes, it's visible.
Okay. So
you can make the video on, because we should come to know who is presenting, right? Yes. Okay. Thank you.
Okay, so we have conducted the systematic review of the existing systems, that how those systems implemented agentic AI, and we have identified some of the characteristics of the agents as well as the agentic architectures that are being used in supply chain management systems. Okay, so supply chain management is
You can make PPT slideshow.
I have shared the screen actually.
I have shared the screen, but make it slideshow.
Is it visible, the slideshow?
Slideshow.
No, ma'am, the slideshow isn't visible. Can you try sharing your screen again?
Is it visible now?
It is on the first page. Can you please navigate, move to next?
It's on the second slide.
No, it is not moving there.
No, ma'am, it's not visible. Can you like specifically share the slideshow itself?
Just a second.
It is not
Yes, ma'am, you may.
slideshow. Yes,
Yes,
yes.
ma'am,
Now,
you may continue.
please continue.
Okay, so supply chain management is one of the most critical and complex industries in today's global economy. And with the recent advancements in technology, the supply chain operations have become highly dynamic, large scale, and interconnected. So, due to this, the traditional approaches struggle in handling the growing diversity, uncertainty, and real time demands of modern supply chains. So, due to this, so basically, to address these challenges, agentic AI is being incorporated in supply chain management systems. And due to this incorporation, they have enabled intelligent agents to collaborate, share knowledge, gather relevant information, and reason over complex scenarios. And due to this, they have given a new level of autonomy and coordination to supply chain management systems. So these systems are powered by diverse data sources, which range from real-time data streams to feedback-driven inputs. And through this data, the agents are capable of perceiving the context, making informed decisions, and adapting to their actions dynamically. So this is an image that is showing the data sources that is being fed to the agentic agents in supply chain management. So what are the characteristics that the agent possess? So these are some of the characteristics that the agents possess. So the first one is autonomy. So the agents that exhibit independent decision making, pursue goals, plan actions, and interact with the environment without human intervention exhibits the autonomous behavior. Goal oriented behavior is another characteristic of the agents, and these are the agents that work to achieve a specific predefined state. And we say that such agents are problem solvers. Then we have another agentic characteristics, which is the environmental interaction. The agents interaction with the environment through sensors or some digital input. Learning capability refers to whether the agent is learning from the experience and adapting to the changing requirements or not. Workflow optimization focuses on creating agents that analyze data, make real-time decisions, and automate complex tasks to overcome inefficiencies. And multi-agent coordination is another characteristic of the agents, which focus on the implementation of multiple agents and coordinations. And however, there are some systems who just focus on one autonomous agent instead of implementing multiple agents. So the systems that we studied, from them we identified some of the agentic architectures that are being used in supply chain management systems. So one of the architecture is multi-agent reinforcement learning. In this, multiple agents interact with the environment and they continuously get feedback from the environment and they use that feedback to improve their decisions over time. So basically, such agents focus on maximizing rewards, and rewards in this scenario would be minimizing overall system costs, improving service levels, and looking for the product quality or inventory related information. Another agentic architecture that is being used is LLM-based agentic multi-agent systems. Here in this system, there are multiple agents, multiple autonomous agents that are powered by LLMs, and each agent is referred to as a supply chain entity and acts as an independent agent. And they use their local data to make decisions based on their goals, and they interact with other agents to achieve global objectives. Then we have another agentic architecture, which is federated learning based agentic architecture. This approach is a decentralized approach for collaborative model training without sharing raw data. So as the data is not being shared, so this ensures data privacy and security across multiple supply chain entities or agents that are being used. And federated learning can be divided into three types: horizontal federated learning, vertical federated learning, and federated transfer learning. So they basically differ in the type of data that is available. So according to the availability of data, we can implement it any of these three techniques. Then we have seen some of the systems which have incorporated blockchain technology as well, and they have done this to enhance transparency through validation checks, smart contracts, and real-time traceability of transactions and product movements. So they have incorporated smart contracts so that they can ensure the execution of agreements such as triggering payments after delivery confirmation, quality checks, meeting inventory thresholds, or checking for um, the product qualities and such things. Then another architecture is the retrieval augmented generation RAG-based architecture. In this architecture, data retrieval is combined with large language models to provide sound reasoning and decision making using multi-source real-time supply chain data. And due to this, we have seen improvement in inventory and restocking recommendations. This has also made the interpretation of demand patterns better and thereby reducing errors and increasing reliability. So another architecture is the hybrid system, which is a combination of multi-agent systems with reinforcement learning. So incorporating these two into a single has actually removed the weaknesses of multi-agent systems and reinforcement learning, thereby improving robustness, stability, and flexibility in the system. So multi-agent system handles decentralized coordination among different agents, whereas reinforcement learning adapts to the changing environment through the feedback. Despite the advantages, there are certain challenges and limitations which are linked with the usage of agentic AI in SCM systems. Like, for example, the systems can experience instability, such as the bullwhip effect. As the data is being used from multiple sources, the data can be noisy, incomplete, or conflicting. As we have different data from different organizations in some cases. So inconsistent data formats can create integration challenges. And as we are relying on AI and there is limited human intervention, so this can lead to cascade failures as well. So to avoid these challenges and limitations, we can adopt certain strategies, mitigation strategies like adopting ethical governance frameworks, ensuring human oversight in some cases, and using explainable AI models. So in this research, we have presented a systematic review on the usage of agentic AI in supply chain management systems. We have identified some of the characteristics of agents along with some of the agentic architectures that are being used in this particular field. And we have seen that organizations who have implemented agentic AI have observed notable revenue growth. And although these approaches do present challenges and limitations, but the benefits of adopting agentic AI clearly outweigh the associated risks. Um, these are the references that I've used in my presentation. Thank you from my side.
Thank you so much, ma'am, for your presentation. Sir, do you have
Thank
any
you.
questions?
Have you identified any use cases?
Such as?
See, you presented various agentic AI architectures, right?
Yes.
So for this use case, this agentic AI architecture is suitable. Have you identified?
We have just studied the existing systems and how agentic AI is being used in those systems. So we have identified the architectures that
So
are
please
being used.
identify the application. This application, this agentic AI architecture is suitable. Okay.
Okay.
Okay. Thank you very much.
Thank you.
Thank you, ma'am, for your presentation. Now I'd like to call upon the next presenter, Bikram Bikash Das, to present his paper titled An Enhanced Approach to Prevent Man-in-the-Middle Attack in Diffie-Hellman Key Exchange Protocol. Sir, you may start presenting now.
Yes, madam. Am I audible, madam? Yeah.
Yes,
Hello.
you're audible, sir.
Yes, madam. Uh, good afternoon, all the members present here. Also, to the sessions here. Good afternoon, sir. And today, I'll be going to discuss my presentation. So let me share my screen. Yeah, madam.
You are associated with NIT?
Yeah, yes, sir. I am associated with National and NIT Silchar, Assam, India.
Okay, please continue.
Yes, sir. So is my screen visible, sir? Yeah.
Visible.
Yes, it's visible.
Yeah. So so let me discuss about my presentation. So myself, Bikram Vikas Das, and I am associated with Department of Computer Science and Engineering at the National Institute of Technologies, Silchar, Assam, India. So today I am going to discuss on the topic of an enhanced approach to prevent the man-in-the-middle attack in Diffie-Hellman key exchange protocol. So so let me so as we know the Diffie-Hellman in security in public network, the security and privacy is important, and in the Diffie-Hellman key exchange is mostly used in all of the security and privacy of a network. So let me let me share full screen. Oh, sorry, sir. Is my slide moving, sir? Yeah.
Continue.
Yes, sir. So these are the outline of my presentation. So today there is an introduction of the Diffie-Hellman and along with followed by the literature review, and also in our proposed approach, so we have used a complex number-based computation. So and also we have given the preliminaries of how the man-in-the-middle attack is in Diffie-Hellman key exchange is possible, and we have given our enhanced proposed protocol along with the results and discussion and concluding and the future work. So let me introduce about the Diffie-Hellman key exchange. So with the rapid development of digital and communication technologies, the secure key establishment over the public and public network is become very essential. So as Diffie-Hellman key exchange is one of the protocol that is used for secretly sharing the keys over a public channel. So suppose like over a public channel like a IoT network or any other industrial IoT network. So the security generally lies on the harness of the discrete logarithm problem, and the traditional Diffie-Hellman key extension does not provide the authentication, and this protocol is susceptible to the attack called man-in-the-middle attack, where the attackers can be able to inspect the incoming and outgoing packages, and he can modify the message in transit and forward some modified packages from the source to destination. And in the objectives of this proposed approach to provide an enhanced version of the enhanced version of the Diffie-Hellman key exchange to in order to defend the man-in-the-middle attack. So by using a complex number-based ECC-based digital signature for authentication, and we also use the symmetric key exchange using the Diffie-Hellman key exchange. So while going to the literature review, so these are the some of the literature that has been based on the Diffie-Hellman key exchange protocol. So the Pandey et al. In 2024, so they have proposed an ECC-based authentication encryption mechanisms. So where the limitation we have found they have some limited security evaluations, and the next one is the electric curve digital signature algorithm framework. So where the limitation is they didn't have any forward secrecy mechanisms. So here in the literature in the proposed different approaches has been used for solving the transmitted shared secret key between the communicating parties. So similarly, some other method in 2020, the classical electric curve Diffie-Hellman analysis is so shown as a vulnerable to man-in-the-middle attack. So there are several resources that has been used that they use the lightwave electric curve cryptography and hash-based authentication, and they are very specific to some application specific areas. And some of the techniques they have used mutual electric curve cryptography encryption where they doesn't have any Diffie-Hellman freshness, and also there are some ECC based RFID authentication where they have found some scalability issues, and also some of the optimized ECC exchange mechanisms has been proposed, so where they didn't have any unauthorized or Diffie-Hellman is a limitation of that approach. So similarly, the Verma et al. In 2024, the latest they have recently 2024 they have proposed electric curve cryptography and AES. There is a hybrid based method where there is no authentication of key setup, and then lastly, they have one paper has been studied in the post-quantum ECC-based study, and the limitation is there are no quantum resistant-based mechanism has been proposed. So several resources has been proposed in order to improve the key exchange schema based on the random number sequence, or also applying some cryptographic hash function to improve the security of the Diffie-Hellman protocol. So next one, so these are some of the notation that we are using for our proposed algorithms. So where the P is the large prime numbers that has been used prime modulus for Diffie-Hellman. The G is nothing but the generator, and E, Z are the elective curve, and Z is the base point, and the order of Z is denoted by N. So the S is the cryptographic hash function, and also we are using the private Diffie-Hellman secret that has been selected by Ellis and Boff, that is both the communicating parties, the A and B, and the small capital AB defines the public values, so which has been computed by Z to the power A mod P, and the B value is computed by Z to the power B mod P. So this is our traditional Diffie-Hellman key exchange mechanism. So in our DA and DB, there is a electric curve ECC private signing keys we have proposed, and after that QA and QB is the public key, so which has been calculated by multiplying the private ECC with the generator and along from both Ellis and Bob. So there is a complex embedding which is denoted by ZA and ZB. So which is denoted like A plus I HA. So I is a complex number, I is like root over -1. So there is a alpha theta and theta B. This is a ECC signature which is based on the complex embedding of ZA and ZB. And the key A and KB are the shared secret key that has been shared between both the communication parties, that is the Ellis and Bob. So let me discuss some of the preliminaries of our proposed approach. So these are in complex. So we have defined a complex number-based key computation, and the main motivation of is to propose the approach that incorporates the complex number with the digital signatures for authentication, and also we are using the symmetric key exchange over the communicating entities. So the complex number is used because it offers a two-dimensional algebraic algebraic system, so that is hard for an adversary or attacker to compute, rather than solving a single discrete logarithmic problem. In a traditional Diffie-Hellman, they are using the discrete logarithmic problem, DLP, but the complex number we have used to add some independent real and imaginary components to the key computation. And this approach remains still a novel. And this private key computation has been components is calculated by z equal to xa plus I, y, and I multiplied by ya. These xa and xb are nothing but the real components, and ya and yb are multiplied with for the imaginary components. And the public key generation has been done for computing the pa and pb by the generative g to the power za for computing the public key computation. The complex embedding has introduced some additional security layers with the traditional Diffie-Hellman key exchange. So let us discuss about the how man-in-the-middle attack in Diffie-Hellman key exchange. So this is the diagrammatic representation of the Diffie-Hellman key exchange. So where the Alice is using some, they both agree on public parameter, that is the Z and P. Z is generator and the public value is 23. And they have computed the public that is being shared between the Alice and Bob, and they computed the values of Z to the power A mod P. So which we are getting as 6, and this is being shared to the this key has been shared to the Bob and transferred to the other communicating parties. And similarly, the Bob also compute the same value by computing the Z to the power B mod P, and we are getting the value 16. So now symmetric key computation, in the symmetric key computation, both the communicating parties, they are using this is the MA is the message for message from the Alice, so which is being computed as 2, and the other parties also compute the symmetric key computation, we are getting as 18. So now after that the attackers can modify the M1 and M2, so Z to the power MA and Z to the power MB, so where the memory comes into the picture, and the attacker can modify the public parameters, and he can change the values to 8 and 4. After that, the attackers, the Alice has seen they have seen the values as 2 and 2, and the Bob also verifies the board has 18 and getting the values from 18. So they think that the Alice can think that this is the values came from the Bob, but actually there is a malicious user who has modified the message, and they are getting some wrong information. So this is a visual representation of the man-in-the-middle attack. So in the proposed enhanced approach, so we are considering the traditional the Diffie-Hellman key exchange. Thus we are enhancing that protocol by introducing a trusted authority. So the trusted authority along with the complex number-based embedding. So in this picture represents yes.
So you have 1 more minute to conclude your presentation.
Yeah, madam. Yes, madam. I'm concluding. Yeah.
Yeah,
So
yeah.
here the session key computation has been done, and the trusted authority is mainly responsible for exchanging the trusted values from the source to destination, and it's responsible for distributing the digital certificate and verifying the authenticity of the signature. And this is the proposed algorithm. So where we have the Ellis generated ECC pairs. There, after Diffie-Hellman secret has been generated by selecting the AB that belongs to ZP, and the computation of Diffie-Hellman has been done by using the traditional Diffie-Hellman exchange, and the complex embedding has been done. And after, there is a signature verification which is done by the trusted authority. If the verification fails, then the algorithm will abort the process, and if there is a matching, then it will say there the secret computation will be computed. So the results and discussion, we are using the Avispa protocol, automated security verification for internet security protocols for analysis. So these are informal security analysis. So here the mutual authentication has been achieved by using the Alice signature using the certified public key. So that ensures the trusted identity verification before the session key establishment, and also it resistant to man-in-the-middle attack. Then there is also we have this is forward secrecy has been maintained because the previously established session keys depends on the fresh ephemeral values. That is, the whatever the previous values are used, that has been used only once, and they are discarded after the use. And the replay resistance, and also they are represent to the Cassia approach. So here in the formal verification in the Avispa approach, so we have seen that the simulation formal verification in on-the-fly model checker approach, backend indicating that the proposed model is safe. And also we have done the simulation on the Avispa for formal verification using the CTATSC, that is constraint logic based attack sorcerer, and the proposed protocol is shown as safe. So these are the security comparison we have performed with the other existing protocol, that is the hash-based message hash-based message queuing authentication factor, and the Sigma, that is the digital signature and message authentication based approach. And let us conclude my presentation. So as we have seen, the Diffie-Hellman is a fundamental, but still it is a vulnerable to man-in-the-middle attack in the public security network. So here we have presented an enhanced version of the Diffie-Hellman key exchange by incorporating the digital signature that is embedded with the complex number for the authentication. And the future research direction, and this work can be done for post-quantum security, IoT optimization, for developing some lightweight protocol for resource-constrained devices. Also, we can this proposed work can be implemented machine learning integration, and formal verification can be done further. And these are some of the reference of my work. Thank you, sir.
Okay, good work. I do not see how the backward secrecy is maintained. I only see forward secrecy.
Yes, sir. So here we have used the forward secrecy mechanisms. So
How
we
the
are
backward secrecy is maintained, achieved.
so backward secrecy. So we are actually till now we are working on this, but forward secrecy
So
only.
please do the analysis of backward secrecy. Okay.
Yes, sir. Sure, sir. I'll
Okay,
take into consideration.
Okay. Thank you very much.
Thank you, sir.
Thank you so much for your presentation, sir. Now I'd like to call upon the next presenter. Dao Khandai, sir, to present his paper titled Cross-Lingual Sentiment Analysis for Low-Resource Languages, a case study on Thai railway services. Sir, you may start presenting.
Hello. Can you hear me?
Yes, you're audible. You may start presenting.
Yeah. So good afternoon, everyone. My name is Duy, and I'm come from the Vietnam Korea University of Information and Communication Technology, the University of Da Nang, Vietnam. And on behalf of the authors, I would like to present our work, which named Cross-Lingual Sentiment Analysis for Low Resource Languages, a case study on Thai railway service. So for my presentation has divided into 5 parts. First, we're gonna see the problem and the motivation of the research. Then we see the objective and the methodology, and then the results, and then finally the conclusion after the results. So the Thai railway operators receive multilingual passenger feedback as well, and Thai is a low resource in this domain, making model transfer difficult. So the existing system often need many labels and high compute cost. So that's why, like in this research, we aim to identify a practical strategy with strong performance and minimal Thai annotation. So in this research, we aim to evaluate the cross-lingual transfer from English, French, Korean, and Vietnamese, and then we transfer into Thai for sentiment analysis in railway feedback. Basically, we compare for multilingual transformer model, which are MBERT, LAW-BSE, LMR, and MT5. And then we evaluate 3 supervision regimes in zero shot, ultra short, and high shot. And then we propose an ultra short strategy for cost-effective deployment in low resource settings. So for the dataset that we use in this research, mainly call from the TripAdvisor with 5 languages. For the original data, we have more than 100,000 of samples, and which consist of 4,000 of Thai samples. And then we solely do data augmentation in English, French, Korean, and Vietnamese. And then for the pre-processing step, we basically removed the HTML and URLs. We normalize the emoji and then use some specific tokenization for a specific language. And then we split data into 3 parts: for training, for validation, and for testing. Then we're gonna use focal loss and then early stopping to prevent overfitting. Then finally, we compare the model in 4 metrics: accuracy, precision, recall, and advanced score. So this is the result when we train the model and evaluate on 4 high and mid result languages. And we observe that MBERT is the strongest and most stable baseline across languages. For the Korean, it remains more challenging, but other models stay relatively robust. And this is the result when we evaluate the model on Thai. And we see that MT5 is the best in zero shot, but when in the ultra short and high shot, the LAW-BSE jumps into the highest accuracy, and that model also achieved the best in the high shot as well. And this is the training dynamics for the ultra short. And based on the that curve, we can see that like for the train and validation loss, it drops quickly in early epochs. Then it's indicating fast convergence. And for the accuracy, precision, recall, and F1 score, it generally increase over epochs, but under the ultra short setting. And then the trend support that the claim that 40-60 Thai samples already provide a strong adaptation signal. So for the key findings, we can observe that the ultra short supervision dramatically narrows the zero shot to high shot performance gap. And for the encoder-based model, such as like MBERT or especially in LAW-BSE, are efficient and strong for low result adaptation. And for the Thai-specific tokenization behavior strongly affects transfer quality. And in practical, takeaway in small and high quality Thai sample can be deliver a high impact. So overall, for the cross-lingual sentiment analysis is viable for Thai railway feedback in minimal annotation. And for this practical strategy, we recommend that fine-tune LAW-BSE with ultra-short Thai data for strong cost performance trade-off. And operators can deploy faster with reduced labeling and computational expense. So for the future work, we're gonna expand by utilize the cross-model learning and your zero-shot reasoning with modern LM, because like the current research also solely rely on the encoder-based model, And also the data source we are primarily using TripAdvisor. Yeah, that's in my presentation. Thank you for your attention.
Okay, what data set you have taken for the same?
For the data set, we crowded from the TripAdvisor and then
Okay.
annotate them. Yeah.
Okay, what is the accuracy you got?
Sorry, can you repeat it?
Accuracy.
Yeah, this is the accuracy when evaluate on the for high and mid visual languages, and this is for the accuracy when we evaluate on Thai.
Okay. Okay, thank you very much. Good work.
Thank you, sir.
Okay. Okay. Next,
Thank you,
please.
sir, for your presentation. Now I'd like to call upon our next presenter, Nazar Melnik sir, to present his paper titled Ensemble Learning for High Precision Prediction of Rare Critical Events. So you may start presenting.
Good afternoon, everyone. Can you see my screen?
Yes, sir, your screen is visible. You can start presenting.
Hello, everyone. My name is Nazar Melnik from the Kiev Polytechnic Institute. Today, I'm going to present you our work on predicting rare critical events with high precision, specifically how to build a machine learning system that raises an alarm only when it's genuinely confident. In a setting where real events are rare and false alarms carry a real cost. So the core difficulty in rare event prediction is that most timestamps have no event. An AI classifier simply learns to say no event almost always. It gets great accuracy, but is completely useless operationally. In civil protection, the cost is asymmetric. A false alarm doesn't just waste resources, it erodes public trust. And after enough false alarms, people stop responding. So that's warning fatigue, and it can cost lives. So we need a system that is not just accurate, but is precise. Most of the alerts it issues should be real. At the same time, we still need to detect the majority of actual events. That's the precision recall tension we are solving. So formally, for each of the region R and each RT, we observe a binary label, alert active or not. We want to estimate the probability of an alert in the next hour and convert it to a binary decision using a region-specific threshold. The dataset for our case study covers 25 Ukrainian administrative regions over 38 months. That's roughly 774,000 hourly observations. The overall alert rate is around 18%. We split it by 70, 15, 15% by time, without no shuffling and no leakage. Our design target is precision about 75%, recall about 70%, and inference fast enough for real-time use. Our pipeline has 4 stages. First is feature engineering. We transform raw binary alert logs into 95 features encoding historical patterns, momentum, and spatial context. Second, we train 2 models in parallel, a deep neural network with a focal loss and a random forest. Their probability outputs are blended with a weight optimized on the validation set. Third, the blended probabilities go through a precision-oriented calibration step, isotonic recalibration followed by per region threshold search. And finally, the system issues a binary alert decision per region per hour in around 12 milliseconds. The 95 features fall into 8 groups. The most important single feature is like 0IH, the current status of alert, because alerts typically last multiple hours, and the 24 lag features capture autocorrelation over the past day, and rolling statistics over windows from 3 to 72 hours capture both short-term bursts and long-term trends. The special features are the key. If neighboring regions are under alert right now, this region is more likely to be the next. So we model that with both national level statistics and adjacency weighted neighbor counts using the actual geographical border graph of Ukrainian regions. Finally, 25 regions identity let the model learn region-specific baselines without any explicit stratification. Though the neural network is a four-layered, fully connected network, also it has batch normalization on the first two layers and dropout at 0.2, 0.2, 0.1. The key training choice is a focal loss with gamma equals 2 and alpha equals 0.6. So focal loss downweights easily negative examples, as the many hours where no alert is clearly not happening and concentrates gradient updates on the hard unambiguous cases near the decision boundary. This directly makes the model more conservative about positive predictions, which is exactly what precision-oriented training needs. Also, the random forest we use uses 300 trees with balanced class weights. It contributes stability and handles heterogeneous features types well, complementing the DNN rather than duplicating it. Also, the blunt weight alpha, which approximately equals 0.6, favors the DNN slightly, found by grid search on the validation of F1. After blending, we apply isotonic regression to correct the probability compression that focal loss introduces. The raw outputs tend to cluster away from 0 and 1. Then the key innovation per region threshold calibration. For each of 25 regions, we scan 199 candidate thresholds and select the one that maximizes F1 subject to precision greater or equals than 75% on the region validation data. If a region has fewer than 30 validation samples, it's too little to calibrate reliably, and we fall back to the global threshold calibrated on all validation data. However, in our dataset, this never triggers because the 15% validation splits gives around 700 observations per region. The resulting thresholds range from about 0.55 to 0.82, higher thresholds for frontline eastern regions with very high alert rates and lower for western regions. On the held out test, the proposed assembles achieves 77.95% precision. That's 3 percentage points above our operational target. Looking at the baseline comparison, the persistence baseline, which just predicts same as now, already gets 74% precision because alerts are autocorrelated, but every single learned model we compare against falls to reliably exceed our operational target. Our model's precision advantage over the best baselines is statistically significant. The Wilson confidence intervals doesn't overlap, and McNemer's test gives p less than 0.001 for 6 of 7 baselines. Importantly, this is not about having a better feature representation. Our ROC AUC is of 92% is actually slightly below XGBoost and LightGBM. The gain is entirely from the precision engineering pipeline, like focal loss and sampling blending and per region calibration. The ablation study confirms which components matter most. The largest single contributor is per region threshold calibration. Removing it and using a global fixed threshold drops precision by almost 10 percentage points. This makes sense because regions with 3% alert rate and regions with 84% alert rate need very different decision boundaries. Second larger is focal loss. Replacing it with standard binary cross entropy drops precision by 6 points. Cross entropy lets easily negative examples dominate training, pushing the model toward a low threshold. The ensemble itself contributes almost 3 points over the best single model. The random forest and the DNN and random forest are genuinely complementary. All differences are statistically significant. The 95% Wilson confidence intervals are non-overlapping for every pairwise comparison with a full model. To summarize, we showed that the three components together, focal loss, ensemble, blending, and with optimized weights and per region precision flow calibration, consistently achieve precision above 75% on a real-world rare event prediction task where no individual baseline succeeded. The most impactful component is calibration, which directly encodes the operational constraint into the decision boundary rather than treating precision as an afterthought. Future directions include richer input signals, graph neural networks usage for spatial propagation, and online adaptation as conflict dynamics evolve. Thank you for attention. I'm happy to take
Okay, how many epochs you have run for different algorithms you mentioned?
Yeah, thank you for question. I don't include that information, but I remember like 25 epochs were pretty much enough for get that precision and accuracy.
Okay. And what is the accuracy you achieved through this?
The accuracy is 92%, but in this scenario, we are more concerned about precision because like it's very critical to have it for the people and for alerts.
Yeah, thank you very much. Next paper.
Thank you.
Thank you, sir, for your presentation. Now I'd like to call upon our next presenter, Sylvia Meschini, ma'am, to present her paper titled Implementing Digital Twin Architecture through BIM and IoT Integration for Sustainable Museums, Maka Living Lab application. Ma'am, you may start presenting now.
Good afternoon, everyone. I try to share my screen. Can you see it?
Yes, ma'am, it's visible. You may start now.
Okay. So, good afternoon. I am Silvia Meschini from the University of Turin, and today I will share with you our work on the Maka Living Lab, where we are implementing a BIM-centric digital twin architecture for sustainable museum or public assets through BIM and IoT integration. It is well known that BIM alone is not enough for operational monitoring, while IoT alone produces data that are difficult to contextualize and also to interpret. So in many digital twin implementations, sensor model mapping are still workflows tool dependent, and the resulting system are hard to scale. In particular, museums make this even more challenging because sensing must be minimal, and at the same time, data should support both technical monitoring and also public visualization. So our goal was to define a BIM-centric, standards-aware and scalable workflow at this aim. Maka is the fifth European Environmental Museum. It is located in Turin, a city in the north of Italy, and it represented a great occasion to implement an ideal test bed as it combines operational needs with also an educational mission. Indeed, the Maka Museum receives more than 34,000 visitors per year. Most of them are school groups. And also the environmental quality becomes both a facility management issue and also a pedagogical opportunity. This project is conducted under the European project nodes, in particular the Spoke 4 framework. It is a European project funded by the European Union and also an RPP. We use Maka as a controlled demonstrator for transferable BIM IoT via sustainable cultural and educational facility. The project aligns with objectives also of the 2030 agenda, in particular the SDGs 11, 13, and I can't remember for the 4. The project represents also a concrete step towards building more sustainable, aware, resilient cities. The core is the 5-layer architecture, this one shown here. According to literature, we separate the physical sensing time series, the storage, and the integration, digital representation, and the stakeholder face interfaces. This is key as it avoids overloading BIM with high frequency histories. And also in our approach, BIM and IFC provide semantic and spatial contextualization with external platforms which remain authoritative for temporal analytics. This dual-layer logic is one of the key contributions of our work for semantic context and also external temporal platforms for analytics. So the monitored scope includes indoor environmental quality variables such as the temperature, humidity, CO2, and also particulate matter, as the MACA is located in a polluted zone of the city. And these values are combined with the outdoor conditions and occupancy-related signals. The important point is that the system is designed for two audiences, staff who need the operational monitoring and also visitors who need understandable and also meaningful feedback. In parallel, we are also extending this ecosystem with indoor localization and also people flow analytics. So the digital twin will progressively support both environmental and also behavioral interpretation. The stakeholders interface layer is able to deliver human-facing data interpretation for facility staff and also for the visitors. The data collected are elaborated and displayed near real time through 27-inch displays powered by dedicated mini PC units and also supported by supervisory control and the web server infrastructure. This is useful to present simplified performance indicators and contextualized narratives derived from monitored variables. A central design choice was also the use of BIM as a semantic backbone rather than a high-detail geometric repository. We bind data to rooms and zones through persistent identifiers, in particular the MACA Space ID identifier, instead of linking each sensor to a specific model object. This makes the system more robust under the sensor replacement and also under some reconfigurations. The same logic is then externalized through a custom IC property set, namely pset MACA IoT. So the selected operational states can be exported in a standardized, aware way and also open format. It was possible to export room-level entities as IFC space objects with the MACA Space ID timestamp and selected also internal environmental quality variables. For example, in the bar zone, zeta bar CO2, zeta bar temperature, and zeta bar humidity were exported as bar CO2, bar temperature, and bar humidity, while the same logic was replicated for the other two areas with sensor, which are the cupola and verde. So outdoor variables remain in the time series layer, and in the current phase, the interoperable change model prioritizes room level indoor stays through IFC space and linked custom properties. So the data bridge is implemented through Dynamo with embedded Python scripts, and the workflow retrieves monitoring records, validates and aggregates them, then evaluates threshold-based conditions, and also is able to write selected values into the BIM shared parameters. Contemporarily, Grafana, an open source software, can support temporal trend reading and KPI inspection using the same persistent spatial logic. So the digital twin prototype works as a dual representation system, BIM for the spatial semantic interpretation and Grafana for longitudinal analytics. In the future, it will be also included AI plugin with LLM such as ChatGPT or vector search, which are able to answer to questions such as which zone had the highest CO2 yesterday, or in the bar zone, humidity is within the comfort range or not, something like that. And this will enable a more user-friendly way to querying the data and get information. The validation confirmed the end-to-end consistency between the monitoring dataset and the BIM environment. So shared parameters were populated correctly, room and zone level mapping powered robust, and IC export remained stable and interpretable across viewers. The Grafana prototype dashboard also confirmed that the same spatial identifier can support filtering and KPI inspection outside the BIM models. In short, the experiment validates a scalable, BIM-centric DT partner rather than a one-off integration. So the main contribution is not just connecting BIM and IoT, but defining a maintainable and standardized aligned implementation logic, which can easily be replicated. Indeed, persistent spatial identifiers, writable shared parameters, IC-based transferability, and the separation between semantic spatial and temporal layers make the approach quite scalable. Of course, there are some limits, such as lim ingestion, which is still under activation, and KPI logic is still in a prototype form. So the next steps will concern live synchronization, the development of richer dashboards, public-facing interfaces, and also a standard occupancy analysis. Thank you for your attention.
Okay, good work. So data set containing how many records?
Sorry, I can't hear you.
Okay. Data set you have referred, na? Data set.
Yes.
How many records it has?
Quite a lot, as the data are collected once every 10 minutes. So we are also dealing with these issues because it is a large amount of data, and maybe we have to find another period to collect data.
Okay. Thank you very much. Next.
Thank you.
Thank you, ma'am, for your presentation. Now I'd like to call upon the next presenter, Sir Murad Aydin, to present his paper titled Information Delivery Specification in the Construction Sector, a Systematic Literature Review. Sir, you may start your presentation now.
Okay, can you hear my voice?
Yes, please continue.
Just a moment. Can you see my screen now?
Yes, please continue.
Okay. Hello everyone, my name is Murat Aydin. I'm currently working as an assistant professor at Ankara University, and I continue my academic studies in the field of project and construction management within the architecture and construction sectors. For many years, I've been working on building information modeling, or shortly BIM, and digital construction process. Today, I will present a new topic, IDS, Information Delivery Specification in the Construction Sector. And this study examines the role of IDS in BIM-based project, positioning it both as a technical standard and a methodological framework. Let's start with the first introduction section. The digital transformation of the construction industry has profoundly reshaped information management and data exchange. Building information modeling, or BIM, has emerged as a cornerstone of this transformation, facilitating interdisciplinary collaboration and improving data quality. The information delivery specification, or shortly IDS, is a new topic and was developed as a standardized framework for defining and validating information requirements in BIM workflows. And IDS was officially approved as a Building Smart Standards on June 1st, 2024. And as emphasized in the official documentation, IDS bridges the gap between human readable requirements and machine interpretable validation rules. These dual role positions IDS as both as a contractual instrument and a technical validation tool, ensuring transparency, reliability, and completeness in digital construction process. Against this background, this study synthesizes the insights from official IDS documentation, academic literature to provide a comprehensive evaluation of IDS role in the construction sector. I will present two examples of IDS document. The first one is figure 4. It's used to define the specification of a 30 centimeter external wall, modeled as IFC wall standard case in figure 4, as you can see in figure. And the next one in figure 5, the IDS document specifies the requirements for a reinforced concrete column modeled as IFC column. This literature review is structured around the themes of emergence and standardizations of IDS, application scenario of IDS, literature review and systematic studies, country and domain-specific studies, and methodological and technical contribution. Figure 6 summarizes which sources contribute to each theme and provides a comprehensive overview of the literature. In this way, the role of IDS in the construction sector is clearly demonstrated from both academic and practical perspectives. This study adopts a systematic literature review, or shortly SLR methodology, and it was chosen because it allows thematic classification of findings. As you can see in figure 7, this study followed a systematic workflow. The process began with the formulation of a research question, followed by a structured literature search across major databases such as Scopus, Web of Science, Google Scholar, and relevant conference proceeding. Search results were screened using inclusion and exclusion criteria. Data extraction was conducted from selected sources, and the extracted data were then analyzed through thematic classification. Finally, findings were synthesized by integrating insights from official IDS. Let's continue with the findings and discussion section. This section presents the findings of the study, and the study highlights several key insights. Standardization of information exchange. IDS provides a mission-readable framework for BIM projects, addressing recurring issues of data quality and transparency. Flexible scope IDS enables validation of both core IFC data and extended attributes as confirmed in application study. Contractual readiness. IDS can be embedded into project contracts as enforceable requirements, a feature supported by building smart data dictionary integration studies. Research gaps systematic reviews review the need for further work on automated compliance checking and nation adaptation strategies. Cooperation of literature and official documentation. As I mentioned in the first presentation, IDS bridges the gap between human readable requirements and mission interpretable validation rules, and this aligns directly with academic findings, which emphasize IDS' dual role in technical validation and contractual assurance. The coherence of theory and practice underscores IDS' relevance as both as a standard and a tool for project governance. To illustrate this alignment more clearly, Table 3 provides a comparative overview of how IDS is positioned in both official documentation and academic literature. And diversity of application domains. As illustrated in figure 8, IDS has been applied across diverse domains: acoustic assessment, accessibility, compliance, railway projects, and energy simulation. And this diversity illustrates that IDS is not merely a theoretical construct, but a practical instrument adaptable to multiple sectors. And search gaps and future directions. This study reveals several areas requiring further exploration. National adaptation. More case studies are needed to standardize ideas across different regulatory environments. Automated complete checking, integration of ideas into continuous integration or continuous delivery pipelines remains underexplored. And methodological development, the linkage between ideas and level of information needs is still in its early stages, and table 4 summarize these gaps and outlines potential direction for future studies. This study concludes that ideas serve as a pivotal framework for standardizing information exchange in BEAM projects. By synthesizing insight from both official documentation and academic literature, the research highlights IDS' role in technical validation and contractual assurance. And in conclusion, IDS has the potential to become a cornerstone of digital construction practices, bridging regulatory requirements with automated validation in big workflows. And future research should focus on expanding niche adaptation strategies, advancing methodological innovations, and lowering adoption barriers for small and medium enterprises. By doing so, IDS can evolve into a truly global standard that supports transparent, efficient, and collaborative construction process. And these are the references I used in my study, as you can see the presentation now. And thank you for listening to me. Thank you.
A good presentation. Any latest references you have used?
Sorry?
What is the latest reference you have used?
Can you say again?
Okay, good presentation, sir. Yes, thank you.
Sorry, I didn't understand your question. Sorry.
No, no. In references, the papers referred up to which year? That I am telling.
Sorry, I didn't understand your question.
Okay, no problem. Thank you very
okay.
much.
Okay,
Thank you.
sorry. Thank you.
Thank you, sir, for your presentation. Now I'd like to call upon our next presenter, Heep L. Ma'am, to present her paper titled Recent Advances in Non-Convex Optimization for Machine Learning. Ma'am, are you present?
I think this is the last, na? The second last.
Second last, we have one more paper.
Okay.
I think the presenter is not present, so I'll just move on to the next presenter. Dao Khan Dai, to present his paper titled Reliability Aware Late Fusion for Robust Multimodal Emotion Recognition Under Modality Imbalance and Domain Shift. Sir, you may start presenting now.
Thank you. So can you see my screen now?
Yes, it's visible. You can start.
Okay, thank you. So again, my name is Duy and come from Vietnam. So today, on behalf of the authors, I would like to deliver our work, which named Reliability Aware Late Fusion for Robust Multimodal Emotion Recognition Under Modality Imbalance and Domain Shift. So we're gonna see the objective and the why we chose that topic, then our method to produce the result, and then the conclusion. So the multimodal emotion recognition combines facial and speech, helps for better robustness, but standard late fusion often use mixed modality weights And in real deployments, modality reliability change due to the visual occlusion, illumination changes, or motion artifacts, or else like acoustic noise or channel mismatch, or also the cross dataset domain shift. So that's why fixed weights can overtrust unstable modalities and degrade the final predictions. So we defined 3 research questions. Why can one modality dominate despite similar unimodal accuracy? And how do entropy, variance, and calibration affect fusion stability? And can we improve robustness without retraining unimodal branches? Then we aim to contribute by variance and covariance analysis for late fusion stability, entropy-driven reliability weighting framework, calibration, aware interpretation of modality dominance, and robustness analysis for degradation and missing modality scenarios. So the first thing first, we're gonna see the reliability aware late fusion framework. Basically, we have like each range outputs like class probabilities. This one is for the facial and then for the audio, and then for diffused prediction, we basically combine both of them. And similarly for class I, so our goal is assign weights based on the modality reliability, not static assumptions. And similarly for variant-based, basically we have like a sigma f squared equal to variance of SF, and sigma a squared equal to variance of SA. And then with weak correlation assumption, we basically can remove 2 WF, WA covariance of SF and SA. And then we minimizing fused variance under WF plus WA equal to 1. So we can say like the lower prediction variance, then the larger fusion weight. And similarly for the entropy-based dynamic weighting, we have the formula of the entropy of modality M, and we can say like when entropy increase and the reliability decrease, and then finally the modality get less weight. And this one is the calibration mismatch, which basically compare the gap between the confidence and the actual accuracy. So the poor calibration can make a modality overconfident but wrong, and the reliability aware fusion downweights unstable confidence distributions. And when we combine with entropy, this improves robustness under domain shift. So this is the unimodal and static fusion result. So after we have the unimodal performance, we can basically have the best static fusion weight, which is like 0.8 for the phase model and 0.8 for the phase model, 0.2 for the audio model. And facial branch dominates static fusion due to stronger stability, not only the raw accuracy. So, and this is the two table complementary errors and robustness. So for the railway environments are dynamically noisy and partially observable, and camera reliability drops in crowding, occlusion, and light transitions. Audio reliability drops with announcement, brake noise, and reverberation. Reliability aware late fusion adapts online by confidence statics, and this supports robust monitoring without retraining the unimodal backbones. So in conclude, we reformulate the late fusion as reliability and static goals problem. Then the framework is practical for safety critical real-world applications such as intelligent railways. And in the future, we're gonna validate on additional cross-domain multimodal emotion datasets. It can from linear late fusion to reliability guided weighting network and deploy it into the live railway pipelines. So thank you for your attention.
Okay, thank you very much. It's a good work. Okay, good.
Thank you.
Yes. Next presentation, please.
Yes, sir, just a second. So right now we're actually done with all the presentations. So I would like to move towards the closing remarks for the session. I'd like to sincerely thank all the authors for the excellent presentations and their contributions in this session, and also all our participants for being a part of this international conference. I hope this session was informative enough for all of us. And we, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027 as well. All the presenters would be getting the digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Lastly, I would like to thank our session chair, Dr. Amar Bhuchare sir, for chairing the session. Here is a token of appreciation to the chair on behalf of Team ICTIS 2026 and Global Knowledge Research Foundation and partners. Thank you so much, sir, for your valuable presence.
Thank you very much. Yes.
Okay, before finally ending the session, I would like to request everyone to switch on their cameras for a quick snapshot. Can everyone please on their cameras? Okay, thank you so much, everyone. You may now leave the meeting. Stay safe and take care. Thank you.
Okay, all the papers were very good. So
Thank
thank
you.
you for giving opportunity. Yes. Thanks.
Thank you so much.
Thank you very much.
Thank you.
Thank you.
Thank you.